Today's lesson is 6-5. Our objectives for today are to be able to determine if an ordered pair is a solution to a linear inequality. We want to be able to graph and solve linear inequalities in two variables, and we want to write a linear inequality given a graph, and finally write and solve a contextual situation. A linear inequality is similar to a linear equation, but the inequality sign, or the equal sign, is replaced with an inequality symbol. You don't have to write any of this down. You have a note sheet. We'll show you where to start writing in just a few minutes. So this is an example of a linear inequality. It's a line, just kind of like what we've been graphing in 6-1. However, notice it has some shading here. That's what makes it different than the equal sign. The inequality means that we're going to either shade above or below. A linear inequality describes a region of a coordinate plane called a half plane. The shaded region of your inequality is called your half plane. A solution of a linear inequality is any ordered pair that makes the inequality true. So that would be any ordered pair in this shaded region right here. So I could pick this point, the point right here, the point right here. Any point in the shaded region would be a solution to that linear inequality. All points in the region are solutions of the linear inequality. That's what we just talked about. The boundary line of the region is the graph of the related equation. So my boundary line is the graph of the line that we drew. So this line right here would be my boundary line. So a couple of different vocabulary words here: linear inequality, half plane, solution, and then boundary line. Alright, now we're going to start on your notes handout, the 6-5 notes handout that we gave you. The first one, or the first couple ones, say tell whether the ordered pair is a solution. So for number 1, our ordered pair is going to be -2 and -4. So go ahead and put -2, comma -4. That's your ordered pair. And they want to know, is this ordered pair a solution to y is greater than 2x plus 1? So we need to figure out if it's actually a solution. So what we're going to do is we're going to plug it in. Basically all we're doing is checking here. I'm going to go ahead and remind myself that that first number is the x and that second number is a y. So everywhere I see an x, I'm going to plug in a -2. Everywhere I see a y, I'm going to plug in a -4. So I'm going to over here say -4 is greater than 2, and instead of x, I'm going to say -2 plus 1. So instead of y, I plugged in a -4. Instead of x, I plugged in a -2. 2 times -2 is -4. -4 plus 1 is -3. So now we have to ask ourselves, is -4 greater than -3? And it is not. So we're going to put a little X right there. It is not. So that is not a true statement. So this one is not a solution. So you're going to write not a solution because it didn't work out. It's not a true statement. So in other words, if I were to graph this, the point -2, -4 would not be in that shaded region. All right, we're going to do the same thing for number 2, except our point here is going to be 3, 1. So the point 3, 1, we want to know if the point 3, 1 is a solution to y is greater than x minus 4. So again, I'm going to remind myself about the x and the y. So everywhere I see an x, I'm going to plug in a 3. Everywhere I see a y, I'm going to plug in a 1. So 1 is greater than 3 minus 4. When I say 3 minus 4, I get -1. So 1 is greater than -1. So then we have to look and say, okay, is it eating the bigger number here? And it is. 1 is greater than -1. So we said this one is a solution. So the first one was not a solution. The second one is a solution. We're going to do the same thing on number 3. Number 3, our point's going to be 4, 5. So 4, 5. Go ahead and fill that in on your worksheet. And we want to know if that's a solution to y is less than x plus 1. So again, my x is 4, my y is 5. So I'm going to plug those in. 5 is less than 4 plus 1. Well, 4 plus 1 is 5, so we get 5 is less than 5. Now this one's a little bit tricky because 5 isn't actually less than 5. 5 is equal to 5, so this is not a true statement. So this one is not a solution. Now, if this one would have that extra mark right here underneath it, then it would have been a true statement because that would have meant that 5 is less than or equal to 5. So that would have been true, but since it just is just a less than symbol, it is not a true statement, so it is not a solution. Please make sure you have all the work down for 1, 2, and 3. Before you move on, if you need to pause the video now, feel free to do that. Alright, so there's our first objective, and it was to be able to determine if an ordered pair is a solution to a linear inequality. Next, we're going to look at graphing and solving linear inequalities into variables. Alright, it says, if we're looking at this equation right here, it says y is less than or equal to, or y is greater than or equal to, means that it's going to be a solid line. If it's just y is less than or y is greater than, then it's going to be a dashed line. So in other words, if it has the extra mark, the line is going to be solid and filled in. If it does not have the extra mark here and here, it's just going to be a dashed line. What this means is that the points on this line are solutions to our inequality. The points on this line, the dashed line, are not solutions. Alright, if we look at this one, y is greater than or y is greater than or equal to, it's shaded above. So if it's greater than, it's shaded above the line. If it's less than or equal to, it's shaded below the line. So greater than shaded above, less than is shaded below.
If you need to sketch that basic idea out on your paper now to keep those two straight, you can do that on notebook paper or on your note sheet if you can make room.
Make an extra mark, make it dark, so fill it in if it's got the extra mark, and this is just a little way to remember that below is less than. Alright, graphing linear inequalities. Our step 1 is to solve the inequality for y. We have to make it look like y equals mx plus b, just like we did in 6-1 in order to graph. Step 2 is we're going to graph the boundary line, and we're going to make it solid if it has the extra mark or dashed if it doesn't. And then in step 3, we're going to shade the half plane. If it's greater than or equal to, we're going to shade above. If it's less than or equal to, we're going to shade below. And then we're going to check our answer. Alright, we're going to go back to your note sheet now. On number 4, we're going to fill this in with what we're going to graph. So we're going to say y is less than 2x minus 3. Alright, so number 4, we're going to do y is less than 2x minus 3 here. And we want to graph the solutions of the linear inequality. So this one's actually already in y equals mx plus b form. So we can go ahead and graph this one. Again, just like we did in 6-1, we're going to start at -3 on the y-axis. So I'm going to put my point at -3. And then here, if it's just 2x, I'm going to put 2 over 1, so I know how much to rise and how much to run. The top number is my rise, so I'm going to rise 2, and it's positive 2, so I'm going to go up 2. My bottom number is a positive 1, so I'm going to go to the right 1. I'm going to make another dot there. I'm going to make a couple more, just so that I have a nice graph. So I'm going to go up 2 more and over 1 more. Alright, now before I start connecting these points, I need to look and see whether or not it has the extra mark here or not. So if I'm looking at this one, it's just less than. It does not have the extra mark, so that means that this one's going to be a dashed line. So I'm going to draw a dashed line on this one. So there's my dashed line. Okay, now that I've got my dashed line drawn, I'm going to go back and look to say, okay, where do I need to shade? And I need to see if this is less than or greater than. It is less than, so that means I'm going to shade below. Alright, so again, I'm going to look and see it's less than, so it's going to be shaded below. And I'm going to shade with a highlighter. If you have a highlighter and want to shade with a highlighter, that's fine. If you just want to shade using your pencil, that's fine as well. So I'm going to look at this line and say this is below and this is above. So I'm going to shade everything below. So there's my shaded region. Hopefully yours looks a little prettier than mine does. That's all right. All right, now we've got everything shaded. We need to pick a point and make sure that we shaded the correct region. So I can pick any point in this shaded area that I want to. I'm going to pick this point right here. I try to make it the easiest point possible. This one's 3, 0. If I can ever use 0, 0, I'll make sure and use that one, but here I can't because the origin's not in the shaded region. So I'm going to use the point 3, 0, my x, and my y. And I'm going to plug it back into my equation. So I'm going to say 0 is less than 2 times 3 minus 3. So 0 is less than 6 minus 3. 6 minus 3 is 3. 0 is less than 3. And that checks out. So we're done with number 4. Please make sure that you have all of the graphing and the check done before you move on. If you need to pause the video now, you may do that. Okay, so now we're ready for number 5. For number 5, we're going to fill in, and it's going to be 5x plus 2y is greater than or equal to negative 8. Now this time, this is not already in y equals mx plus b form for us, so we've got to actually move some things around before we can graph. My 5x is on this side and it needs to be on the other side, so I'm going to subtract 5x from both sides. I'm going to bring down, I've got 2y is greater than or equal to negative 5x minus 8. And again, make sure you know that you can't actually subtract those. That 8 does not have an x. We always list the x first and then the number. Now I'm going to divide everything by 2. And that's going to give me y is greater than or equal to negative 5 over 2x minus 4. So now I'm ready to graph. Now this looks like y equals mx plus b. So I'm going to begin at negative 4 on the y-axis, since that's my end number there. So on the y-axis, 1, 2, 3, 4. I'm going to put my dot there. And then here, I know some of you are still having issues knowing which direction to go and making sure that your line is going in the correct direction. So what I always like to do is I always like to make sure that my negative goes to the top of my fraction. So that way I know that I'm going down 5, and then I don't have to worry about whether I'm going left or right. I'll always go right if I put that negative on the top. So here it's negative 5, so that tells me to go down 5. 1, 2, 3, 4, 5. And then again, if I put the negative on the top, I'm always going to the right, because that 2 on the bottom is positive. So there's my 1 point. Now I'm going to go the other direction. 1, 2, 3, 4, 5. And over 2. So there's my other point. Now I'm going to look and say, okay, this one does have that extra mark. So I'm going to go ahead and make that a solid line. Hopefully, again, your line's a little bit better than mine. All right, so then we're going to look and say, okay, which direction are we going to shade? So then we're going to look to say which area we're going to shade, and we look and we say, okay, this is a greater than symbol, so that means I'm going to shade above the line. So I'm going to look at the line and say this is above, and this is below, and I'm going to shade that above region. This time I'm using a coloring pencil. It works a little bit better than my highlighter did. Alright, so now that I have everything shaded, I need to pick a point in order to check. And this time, looky there, that 0, 0 origin is in my shaded region, so I'm going to pick that one. It's always the easiest one. So for my check, I'm checking the point 0, 0. So everywhere there's an x and a y, I'm going to put in a 0. 0 is greater than or equal to negative 5 over 2 times 0 minus 4, which gives me 0 is greater than or equal to negative 4. Alright, I got in a little bit too big of a hurry there. I always need to go back to the original to check. So here I'm going to say 5 times 0 plus 2 times 0 is greater than or equal to negative 8, which gives me 0 plus 0 is greater than or equal to negative 8, which gives me 0 is greater than or equal to negative 8, and that's a true statement. Make sure you have all of the work for the graphing, the solving for y, and the check done before you move on. If you need to pause the video now, feel free to do that.
All right, so let's go ahead and look at number 6 now. The first thing we're going to do is go ahead and put our inequality sign into our problem. So we have negative y is less than x. Negative y is less than x. So the problem here is that I can't have a negative y because y is technically not solved for. Again, it has that understood 1 in front of it. So when there's a negative 1 there, I have to divide everything in the problem by a negative 1 in order to make my y positive. The other issue here is that I'm dealing with inequalities, and you may or may not remember that when I multiply or divide both sides of an inequality by a negative number, I have to flip the sign in the middle. So I want you to draw the little flippy arrow here to show that you're flipping the sign so you don't look back on it later and think, what was I doing there and why did my sign flip? So negative 1 divided by negative 1 is going to cancel. It's going to give me y, and it's again going to flip my sign so it becomes greater than, and then it's negative 1x or negative x on that side. So now I can graph my line. This is a direct variation equation, y equals kx. And that means that basically my begin or my b is plus 0. So it's the same thing as saying plus 0. So I know that I'm going to begin at the 0 because there's nothing here in my problem. So my slope is negative 1. If I'm to write that as a fraction, it's negative 1 over 1. So like Ms. Singh was saying, it can be easier to always keep our negative with the top number of the numerator. So that's what we're going to do. So the first thing we're going to do every time is go down 1. And then we're going to go, because we already went negative 1, we're going to go positive 1 and make my dot. Down 1, positive 1. Negative 1, positive 1. And I can come back up here and do the same thing. Oops, if I do it right. And there's my line. Ignore my little rogue dot out there. So now I'm going to take my ruler and draw a line. But first I'm going to check my inequality sign, and over here I see that I don't have an extra mark underneath my inequality sign. So before I draw this line, I need to pay attention to the fact that it is going to be a dashed line. So I'm going to put it in my dashed line. Draw my arrows on either end, and now I can shade. Because it is y is greater than x, I'm going to shade above the line. Because it is a greater than sign, I am shading above the line. Now I know we really like to check with 0, 0, but I can't check with 0, 0 here because this is a dashed line, and even though the line crosses through 0, 0, it again is dashed, so that 0, 0 is not a part of the solution set here. So I'm going to choose 1, 1 to check with. I'm going to choose 1, 1 because it is in my solution set. So now I can come back to my original problem and check. I'm going to say negative y is less than x, and for negative y I'm putting in my 1 is less than 1, negative 1 is less than 1, and that checks out. So make sure you have the work and the check written down before you move on. All right, let's go ahead and write the problem for number 7. Number 7 is negative 3y is greater than or equal to, negative 3y is greater than or equal to negative 6x plus 3. So I have to first check and see if it's in y equals mx plus b form, and this is not in slope-intercept form because I have a negative 3 in front of my y. So the first thing I have to do is divide everything in the problem by the negative 3 to get that away from the y. So some people write it one time over here. I like to write it out 3 times because I have a hard time remembering, or I think we have a hard time remembering when we do one bar that we divide both of these by negative 3. So here this cancels, and it leaves us with y. Okay, I divided both sides by negative numbers, so I have to flip my sign as well. I almost messed that up. So that cancels y, and again I want you to draw the little flippy arrow to remember why you flipped this sign. And then negative 6 divided by negative 3 is going to give us positive 2x, and then 3 divided by negative 3 is going to give us negative 1 or minus 1. So now we're going to graph this line. Alright, so my begin is the negative 1, so I'm going to come on the y to the negative 1 and make my first point, and then my slope is 2, which is the same thing as saying it's 2 over 1. So I'm going to come up 2 over 1, up 2 over 1, and then I can come back here and go down 2 and back 1, down 2 and back 1. Now I'm going to draw my line, and because I have an extra mark underneath my inequality sign, I know that my line is going to be solid. Again, it's important to note that before you draw the line. And now I'm going to look and see which way I'm going to shade. So because it is y is less than, I'm shading below the line. I'm shading below the line here. And then I'm going to pick my point to check. Again, I always like to pick 0, 0 if it's in the shaded region, but here it's obviously not, so I'm going to have to pick something else. So I will go with 2, 1 here. So I'm going to go with 2, 1, which is right here, sorry. 2, 1. And that's what I'm going to check with. So I'm going to come back to my original problem, which is, I'm going to write it out, negative 3y is greater than or equal to negative 6x plus 3. And I'm going to plug in 2 for x and 1 for y. So negative 3 times 1 is greater than or equal to negative 6 times 2 plus 3. Negative 6 times 2 is going to give me negative 12 plus 3. And then over here I have negative 3. Okay, and then I'm going to work this out. It's going to give me negative 3 is greater than or equal to, and negative 12 plus 3 is going to give me negative 9. And that does check out. Negative 3 is greater than negative 9. Make sure that you have all of that down. You can pause the video if you need to. Alright, starting with number 8, we're just going to be writing, an inequality to represent the graph. So, I want you to go ahead and write out the basic foundation for the inequality, and then we're going to come back and kind of fill in the blanks. So you know that you got to get it in y equals mx plus b, or slope-intercept form. So I want you to write y, and then I want you to put a circle for your inequality sign, and then blank x plus blank. And now we're going to fill in those blanks. So the first thing you can do is figure out where your b is, or where you begin, which is where your line crosses the y-axis. So it's right here. So go ahead and make that point, and we can fill in our b. It's a positive 1. So it's 1 on the y-axis, so we can just put a 1 there. That's our begin. And now we can count our slope. So to count our slope, I'm going to look and see if I can find a spot where it really intersects, like right at the corner of a square. And I think that right here, sometimes it's kind of hard to tell, but I think that right here it really intersects. And ultimately, if I go a little bit too far, I can always reduce down my fraction so it's not the end of the world. And I'm going to kind of draw this little triangle out here, and that's going to help me count my rise over run. So my rise is going to be 1, 2, 3. And my run is going to be 1, 2, 3, 4. So I rise 3, run 4, and I'm going to write that 3 over 4. So 3 over 4, x plus 1. And now my only step left is my inequality sign. So I have to look at my line. I know that I'm not going to have an extra mark because you can see that my line is dashed. So it's just going to be less than or greater than, and I'm going to look and see which way it's shaded. It is shaded above the line. So it's going to be y is greater than, because it is shaded above the line. So y is greater than 3/4 x plus 1 is the equation for that line. Now let's look at number 9. Again, I'm going to say y is either less than or equal to blank x plus blank. Now here my b, or my begin, is actually 0. So when I fully simplify this, it would actually just be y is less than or equal to blank x. Now I'm going to count my slope. It goes back 1, up 1, back 1, up 1, or up 1, back 1, up 1, back 1. My rise over run is 1 over 1. Now, because I am going up 1 and back 1, or down 1 and over 1, that is negative 1 over 1, down 1 over 1, negative 1 over 1. And I'm shading below the line, so it is less than. And because it is a solid line, it is less than or equal to. I'll neaten that up a little bit with some whiteout. Hold on. It's going to be less than or equal to. So I'm going to go ahead and rewrite this. That's the same thing as y is less than or equal to negative 1x. Because I told you we leave off that 0, so this is actually my fully simplified answer here. Y is less than or equal to negative 1x.
All right, guys, number 10. Again, we're going to start this out the exact same way. We're going to say y. I'm going to circle blank x plus blank. And now if I'm looking, it's going to cross the y-axis right here at negative 2. So my b is going to be negative 2. And if you look, this is a horizontal line, and we remember that horizontal lines have a slope of 0 because we rise 0 and we run 1, so 0 over 1 is 0. And then we have to look, it's shaded above, so it's going to be greater than. And it does have a solid line, so it's going to have that extra mark. Now I'm going to clean this up just a little bit and say y is greater than or equal to, and then 0 times anything is 0, even if it's 0 times x. So this actually just kind of cancels, and I'm left with negative 2. So y is greater than or equal to negative 2 for number 10. Now I want you to take a minute and pause the video and try number 11, and then restart when you're ready, and you'll see if you got the correct answer. Hopefully you've had a minute to try number 11. You should have gotten y is less than negative 4 over 1x minus 3, or simplified y is less than negative 4x minus 3. It's shaded below, so it's less than. It's dashed, so there's no extra mark. I would have had to have went down 4 and over 1 to have gotten my slope here. So that's negative 4x. And then it crosses the y-axis right here at negative 3. That is the end of your video. Thank you for watching.